Hey, g'day, it's Prezzo. Thanks for joining me in the workshop today. Now, today's sticker came to me all the way from Germany, a place called Gerolstein, and it was sent to me by Christian Hims. Now, Christian is a German model engineer, as you probably guessed, and he's building a beautiful little steam locomotive. It's a model, an accurate scale model of a French engine called a de Carvel, or de Corvel. And it's an O2OT locomotive. Now, the French classification system for locomotives is different to England. In France, they count the number of axles rather than the number of wheels, but essentially it's a four-wheel narrow gauge steam locomotive, and like everything made in Germany, the craftsmanship is extremely good. So please check him out. I'll put his link up above here. So if you have any interest at all in steam locomotives or engines in general, it's worth checking out. Now, speaking of engines, today is episode 3 of the Titan glow plug engine build, and this thing has just gone off. Couldn't believe the number of views that I got on the first episode. The second episode's going the same way, and it's amazing how many people are interested in this build. So that's a good thing for me, good thing for you. But let's head over to the bench and have a look at what we're doing today. In the last episode, we got through machining most of the crankcase. Now, there were still a few items to be done. One of them is machining the flat face on top of the crankcase where the cylinder will be bolted, and we'll also have to do the exhaust port. So those two things are happening today. We're also going to machine up the bronze bush that carries the crankshaft. Now, speaking of the crankshaft, this is where I have to admit to you something quite painful. It's true, I've been living a lie. I know, you're thinking, does this look like the face of a man who would lie? Well, how do you explain this? That's right, 2 crankshafts. Now, if you're looking at this now, you can see there's an obvious difference between these 2 crankshafts, and this is the one that I did in episode 1. Now, I machined this up from the stock that was supplied in the kit, and I was totally happy with the way it turned out. Everything was spot on for diameter, thread turned out great, all of the eccentric turning at this end went well, and I was totally happy with it. And to be fair, this crankshaft here, the one in episode 1, was an accurate representation of the drawing that I had done. The only problem is that the drawing was wrong. Now, this is not the drawing that I was supplied with. I went ahead and actually modeled the crankshaft in my CAD program, and I did that so that I could get dual measurements for all of the cylindrical turning that had to be done on the main part of the shaft here, because I work mainly in metric, and I also could rearrange the dimensions so they were all positioned from one end of the crankshaft. Unfortunately, I overlooked one single dimension. Now, anybody who's done any work with CAD drawing would know that leaving an unconstrained dimension in a model is almost a sackable offense, and that's exactly what I did. So this one dimension here, from this shoulder up to the back of the crank disc here, I'd drawn a line, but I hadn't put a dimension on it. I dimensioned everything else, and of course you can make the model and it looks fantastic. Now, it was only after I had machined up the crankcase that I put this through the bore of the crankcase and realized that this section here, which is where the prop driver will go, was in the wrong place. And feeling like an absolute idiot, I decided that it had to be made over again. Now, as it turned out, I had some 4140 steel to make the second crankshaft. Now, this one is 1018, this one's 4140. 4140 is a much better steel for this application, and having done the first one, I knew the workflow for the second one, and it turned out equally as good, probably better actually. I think I did a much better job on the thread, and I was able to get this section of the crankshaft more parallel. This one has a very, very slight taper in it. This one's pretty much spot on. So doing it a second time over was probably a good thing. And I also went ahead and actually made a second drawing. So this one here shows the entire engine in cross section, and this allowed me to verify that I had the crankshaft right. So this is the prop driver, and it needs to be clear of the end of the crankcase casting by a couple of hundredths of a millimeter. And I can zoom in on this drawing and I can see that I have that clearance there. So yeah, lesson learned. It's probably a good idea to actually model all of the parts and check your assembly before you go ahead like a mug and machine the wrong part. So there you go. I've admitted on camera that I make mistakes. I mean, you all know that. And I'm pretty sure that we all do this, you know. It's just that when you commit yourself to making a YouTube series and things go wrong, everyone gets to see it. So that's what's happened. Anyway, let's head over to the milling machine and let's get busy with the crankcase casting. Now, I know I did this operation in the last video, and all I can say is I screwed up somewhere. Maths was never my strong point, and when I was offsetting from this piece of PVC, something went wrong. And it wasn't until later, when I took it out of the vise and checked it carefully, I realised that I'm about 2 millimeters too high on this surface here, so it's a mistake, but in a good way. It's recoverable. So the other thing that alerted me was I looked at the drawing, and this surface of the exhaust port here is meant to be flush with this surface here, which is where the cooling fins will bolt down. So that's what made me think I'd made a mistake somewhere. Anyway, I'm going to do this now with my fly cutter, and I'll check it with the depth micrometer just to be sure I've got it right. It's a pretty heavy cut for a fly cutter, but it means that the last cut I do will be a bit lighter and leave a better finish. Okay, well that's exactly the same as the drawing now. That's how it's meant to look. So let's go ahead and get this exhaust port machined out. The last operation I need to do on the crankcase at this point is to machine the exhaust port. Now, I'm sure you've realised by now that there are very few reference surfaces on this casting that I can access when I go to do things like setting up for this operation here. So what I've got is a steel plug fitting in that bore there. And this is going to allow me to indicate off both sides of that bore, and I can then step in the correct distance from this face here and start machining out the port. Now the port has to be 3/8 of an inch wide, and there are dimensions shown in the drawing for the length of the port, and it needs to be split in the middle, as you see later. And the other thing is that it's just an awkward thing to hold, and it's awkward to set up. But what I've been able to do is to indicate vertically down this plane here, and hopefully it's not going to let me down, but there's the indicator sweeping down that face there and showing 0, and I should be able to sweep across that way. So that is all aligned the way I want it. So what we'll do next, we'll indicate in the steel plug, and then it can come out, we can get rid of it. It's just to find the center of the bore. Okay, I'm going to set the half function on the y-axis on my DRO, and we'll find our way to the center of that bore. Okay, so I'm going to lock the y-axis there. So now what we'll do is come in and touch off against this surface here. Okay, so now we're touched off here and we're going to offset the correct distance to the center of the exhaust port. So what I've got here is a 3/8 slot drill, and I've got everything lined up. I've done my offset from this face here to get the center of the exhaust port, and I've offset from the center of the port to the very end. And I can take that steel plug out now, and then what we can do is just lower the quill. Now I've set my depth stop so it'll go to the correct distance, and this first part of the slot will go all the way across, and then we've got to do 2 smaller slots either side of center, leaving a sort of a rib in the center, which is used for an anchor point for one of the cylinder head studs. So we're just going to plunge this and then advance the table toward me, just taking small bites as we go across, and then we'll do a sweep to finish off. Now I'm extremely nervous about this. I've gotten this far without too many mishaps, and you know, this is probably the last major operation to happen on this, so I really want it to go right. And I've thought about all of the possibilities can go wrong. I think I've covered them all, but what can we do? Okay, sort of hoping that looks right. Now we're going to sweep back the other way now with the cutter held at its correct depth. So I switched over to the ball nose end mill, and the 2 short slots are now 7.3 either side of what will be the center, and up to 14.28, which should be the end of this original pocket here. And the cutter should break through into the bore of the cylinder. So again, I've set the knee to the correct depth, set my depth stop, and I'm just going to use the quill to take successive cuts down to that depth, and then we'll clean it up in one last pass. Again, very nervous about this. This first cut should be just to this side of center, and then we're coming out all the way to the end of the pocket. Okay, that seemed to be okay. Now I'm going to do the other one off camera, or I might shift the camera, we'll do the last one, and then we'll come back and have a look at that, because that then is done, and we can move on to another part of the engine. Well, I think I can breathe a sigh of relief now, having done most of the major operations on this crankcase casting. And just remember, this is the only part that I can't remake. And cutting this exhaust port was giving me lots of nightmares. I had to do lots of conversions from imperial to metric dimensions. And you can see I've got notes all over here. I've got another page here. I've been scribbling down dimensions. And part of the problem with these drawings is it doesn't always give you functional dimensions. So, for example, with the length of these ports, it just gives you the distance from one circular end to the other circular end point. What you really want is the distance from centre to centre. And because I'm doing the conversions from imperial to metric, there's lots of places where things can go wrong. So I double-checked and triple-checked my measurements, and I hope I got it right. But as you could see before, errors do creep in, but we were able to recover from that one. And the other thing that's worth noting is that this exhaust port is really not a really accurate part of the timing to do with the engine. That all happens with this part, which is the cylinder liner. Now it will have some windows cut in the outside of that liner, and they allow the piston to get the timing correct for the transfer of gases from the crankcase to the top of the combustion chamber. So this is the part that needs to be super accurate. This is really just like an escape path for the hot gases, that's all. Alright, now the next step is to make the bushing that goes inside the crankcase bore, and that's a sort of a bronze material. We'll go and do that on the lathe now, and let's hope we can get this part ready and finished, and then I'm going to have a go at actually lapping the crankshaft. So we'll ream this to size and not touch it, and then we'll try to get the crankshaft to size by doing an external lapping operation. The material we're using for this crankshaft bushing is a leaded bronze, so that's an alloy of copper, zinc, tin and about 2% lead. It's supposed to make a nice wear resistant material for this bushing. So let's go ahead and get this baby machined. Got a feeling that moved in the chuck. Just going to face it again just to be sure. Okay, so I'm going to drill this just under size and then bore it, and then we're going to ream at 9/16. I don't know if you saw that, but that drill bit grabbed just after it got started. This is a very sharp 12mm drill bit, and the problem with these is that they have a fair amount of rake on the cutting edge, and with brass and bronze materials like that, they really need to have zero or negative rake, and that's what happens. It can quite often pull the drill bit into the stock, and if you don't have it really tight in your tailstock chuck, it'll just either pull the chuck out or it'll pull the drill bit out. But luckily I got away with that. It's just a preliminary cut just to make the bore parallel, and I want to go to 14.1, which is just slightly undersized, and the reamer will do the rest. So I've got about 2 mil to come out of there. Well, that was the last cut that I dare to do with the boring bar. You can see the reamer is now starting to enter that hole, so it's going to be just the last 3 or 4 thou taken off by the reamer. And after we've pressed this into the crankcase bore, we'll ream it again just in case pressure of inserting that into the bore has collapsed it in any way, but I doubt that's going to happen. Okay, I've got the spindle set to a fairly low speed, low RPM, and I've got the tailstock loose, and we're just going to slide the tailstock in and out again in one action. And I'm doing this dry with no coolant or lubricant. It should be self-lubricating. And that should be it. Alright, that's what I was hoping for. So that crank shaft is just barely entering, and that means that I can afford to lapse some material off the crankshaft to make it a really nice fit. So that's worked out well. So we're going to face and chamfer both ends now, bring it back to the correct length, and then mount it on a mandrel to do the rest. Right, so I've got to take this out, measure its length, and work out how much material still needs to come off. And we're going to leave this a couple of thou over size. That should be machined to length now, plus a couple of thou extra, which will be trimmed off later. And we can mount this on a mandrel now and finish off the outside. Right, this is a steel mandrel that I machined up, and it's been in this ER40 collet chuck, and I haven't taken it out. And I also marked the first end of the brass bushing that I machined. So this one should be absolutely square to the bore that we reamed. The other end isn't so important. And we can slide that on there, and then there's an M6 thread, and I can use this little clamp to hold that on there. Now this steel washer here is too big, but it doesn't matter, I'll just machine that down as we go. And what we need to do now is to machine this so that it's a very slight interference fit in the casting that we've already made. And I've made up like a gauge, so I can check our progress as we go. But once again, this is one of those really critical operations. If this is loose in any way at all, it's sort of ruined. If it's too tight and we press it in, we could crack the casting, so really have to get this right. So if I don't talk too much, it's because I'm concentrating, and I just saw the evidence which tells me how much this slid when I was doing the initial drilling. So that was just my bad. I didn't tighten the chuck enough, but as it turned out, it didn't matter. Alright, so let's get this cleaned up. So this diameter here, I'm just getting this set now, this will become the diameter of the boss on the end of this this bushing, so it's not so critical, and I'll get it right. Oh, that's great. It's already undersized. So this is meant to finish at 3/4. I'm guessing this was sort of a nominal 3/4 diameter. But like I say, it's not that critical. I think I'll just clean it up and that's all. Yeah, it's about just under a thou under its nominal size. Just barely clean that up. Okay, now this is the important one. We need to get this absolutely dead nuts right. It's a better finish. Yeah, 0.5. I'm just second guessing here, but that should not go in there. As you can see, it sort of wants to get started, but it won't quite go. So I'm happy that that's right. Alright, that should be it. Okay, so this is how this should work. The bush should be a really snug, almost a press fit in the bore of that casting there, and what I'll eventually do is heat this casting up, and then the bush should just drop through, and then as the casting cools it should shrink back around that bush there. Now the little raised section that we left on the end of the bush there is what the end of the crankshaft disc will run against. So this surface here, the only contact between the bush and that disc is just that raised land there. So that needs to remain lubricated while the engine is running. And of course that should not fit in there yet, so we're going to lap this section here to get everything to fit correctly, and Bob's your uncle. Right, so I'm going to wind this episode up here now. Let's head over to the bench and wrap this up. Okay, I hope you enjoyed that today. In the next episode we're going to go ahead and we're going to make a lap for the crankshaft. Now this is what I'll be making it from. It's a piece of 6061 aluminium. It's a type of lap that I saw on Robin Renzetti's channel. Won't be as good as his, but it'll do the job. And we're going to try to get the last couple of tenths off the diameter of that shaft there and improve the surface finish. And then we should be able to allow this to run with a nice running fit in that bronze bush there. Now also some people have asked why there are no mounting lugs on the side of the crankcase, and that's because this engine has what they call a bulkhead mount, and that's this casting here, That forms the seal in the back of the crankcase, and will also have 3 holes drilled in it so you can screw the engine direct to the bulkhead of the model aircraft. So if we get time, we'll make that part as well. Thankfully, this is a pretty straightforward part, and I'm hoping that the worst of this engine is behind me now. Still got a couple of challenging parts to come. That's going to be the piston and getting a really good fit inside the cylinder liner. But hopefully by then I'll be on top of this lapping business and we can make that happen. So that's it for today. Thanks for joining me. I'll check you on the next video, and thanks for watching. Getting quite the collection of stickers here, you know. That's great.